Hi guys, welcome back. Today we're talking about tangent lines. Hope yesterday you guys were okay with the intro to circles. Tangent lines. We talked about this a little bit yesterday. We had a theorem that said a line was tangent if and only if it was perpendicular to the radius. So I know this guy here is tangent, my tangent line, meaning it only touches my circle one time right there, and that is your point of tangency. It is tangent if it is perpendicular to a radius. If it's perpendicular to a radius, we know that it has to be tangent. So that was the if and only if. We could read it both ways. Again, you only have to know one of these. If your line is tangent, then you know that it's perpendicular. If you know that a line is perpendicular to your radius, then that line must be tangent. Again, you just need to know one of them, and then the other one would have to be true. Another theorem that we covered was if you have 2 points here, my x and my z, those guys are both my points of tangency. They are coming out to the exact same external point. These guys here are both tangent. Then we can say that these two guys have to be congruent to one another. So we're going to be working with these two facts today, these two theorems. My first question, Amiko is riding her bike on a wet street. As the bike wheels spin, water drops are sprayed off tangent to the wheel. So this guy right here is going to be my tangent to the wheel. Wherever it's tangent, that is your point of tangency, and that is where your right angle is formed. A lot of times students want to put a right angle somewhere else. Right at that point of tangency on your circle, that creates your right angle. Amiko's bike wheels have a radius of 12 inches. We want to find the distance, this guy right here, that the water drops have been sprayed when they are 13 inches from the center of the wheel. So 13 inches away, that's where this 13 comes from right here. This is not a radius because it's going to keep on going on the outside here. We want to figure out what that value of x is. So when I set this up, we see we have that right angle. So we can go back to our right triangles, back to Pythagorean theorem. So I'm going to get x squared plus 12 squared is equal to 13 squared. Or if you remember your Pythagorean triples, this is a 5, 12, 13 triangle, which means x is equal to 5. If you don't know that, you would just have to solve this guy right here and you would get that x equals 5. My line L is tangent to circle P at A. So again, right here, that is your point of tangency, which means you're going to make a right angle right there at that point of tangency. And we know that CB, just this little guy right here, has a length of 8, and AB has a length of 20. We want to figure out what the radius is. Well, going from your center out, this is your radius, and we know that all radii in a circle are the exact same, so this guy here is going to have that exact same value, so we're going to call him R as well. My question, though, in order to find R, I have to look at my hypotenuse, which is this entire side right here. So here are my two legs in my right triangle. I have R as one of my legs and 20 as one of my legs, but my hypotenuse is going to be R plus 8 together. So I'm going to have this equation. R plus 8 is my hypotenuse, R squared plus 20 squared. When I solve this, I remember before we were having lots of problems, we forgot how to FOIL. First, outer, inner, last, we're going to multiply R plus 8 squared, which is going to give us R squared plus 16R is equal, let's go back on that. R squared plus 16R plus 64 is equal to R squared plus 400. Again, the R plus 8 squared is R plus 8 times R plus 8, which gives you R squared plus 16R plus 64. Then I notice that I have an R squared on both sides, so I can just cancel out my R squareds. Those guys go away, and I'm going to subtract 64 from both sides. So I'm going to get 16R is equal to 400 minus 64 is going to give me 336. Divide both sides by 16, so I'm going to get R is equal to 21. If you were good with that problem, you can go ahead and pause to see if you can get this one all on your own. Otherwise, we'll keep on going here. A green on a golf course is in the shape of a circle. So here's our circle, our green, right? A golf ball is 8 feet from the edge. So just this little guy out here is going to be our measurement of 8. And it's 28 feet away from the point of tangency. So that's my point of tangency. Then I know automatically that I'm going to have my right angle right there. Assuming that the green is flat, I want to know what is the radius of the green and also how far is that golf ball from the cup at the center. Again, I'm going to call this guy R because this is my radius going straight out here, and this guy here is also going to be my radius. When I set up my equation, I'm going to get R squared plus 28 squared is equal to R plus 8 squared, because again, this hypotenuse is everything all together, R plus 8. So I'm going to get R squared plus 28 squared is 784, and that's equal to R squared plus 16R plus 64. Again, I'm going to subtract R squared from both sides. 784 is equal to 16R plus 64, subtracting 64 from both sides, and I get 720 is equal to 16R, which means R is equal to 45. So your radius is going to be 45. But careful, the second part of our question says how far is the golf ball from the cup at the center? Well, if this guy here is 45 and my golf ball is way out here, I'm going to take my 45 and add it to 8, which gives me 53. Let me go back on this. You're also going to get questions on your homework tonight where it's going to ask you, is your line tangent? So again, if you're going to figure out if your line is tangent, we can come back to this guy here. If your line is tangent, then it has to be perpendicular. So you're going to use Pythagorean theorem converse, and you're going to check, do you make a right angle? If you do make a right angle, then yes, your line is tangent. That's how you're going to check that. So they're going to tell you it's tangent, you can find the radius, or they're going to ask you, are you tangent? This case here, if it looks like it's tangent, it is tangent. They're not trying to fool you. So here it looks like it's tangent, which means I'm going to have this right angle here. Careful though, it's not saying, you're not using 6 as your length here. You have to double it because it's going all the way straight through, because here is your right triangle, this big guy all the way around. So when you set this one up, you're going to set it up as 12 squared plus x squared is equal to 25 squared. 144 plus x squared is equal to 625. X squared is equal to 481, and then 481 is not perfect, so x is just equal to rad 481. So be careful if it's a radius or a diameter. Either way, it's still a right triangle because your point of tangency, it does make that right angle on the bottom there. And the other theorem that we talked about said that if you had a point coming out to the same external point, then these guys here are going to be congruent to each other. So to solve for the value of x, all I have to do is set these guys equal to each other. 2x plus 13 is equal to 4x minus 8. And I'm just solving for x here. So I'm going to minus 2x from both sides. 13 is equal to 2x minus 8. Add 8 to both sides. 21 is equal to 2x, which means x is equal to 10.5. And this guy, if you want to pause and see if you can figure this one out on your own, go ahead. All right, so again, using that last theorem that we just talked about, going out from this guy here, we know this guy has a length of 19, which means over here is also going to have a length of 19. That guy is 19, but my entire length is 31. To figure out what this little guy is right here, I'm going to take my 31 minus 19, and that leaves me with 12. But then I know this guy right here is also going to have a length of 12. So I have those two sides, those two parts, 19, 19, 12, and 12. I have to figure out this length here. But again, since they're going out to the same thing, I know they're congruent to each other. So I'm going to set this up as 4x plus 1, and that is equal to 9x minus 44. Subtracting 4x from both sides, 1 is equal to 5x minus 44. Add 44 to both sides. 45 is equal to 5x, which means x is equal to 9. Now careful, that's just what your x is equal to. You have to figure out what the length is, which means you have to take this x and plug it back in to one of your sides. So I'm going to do 4 times 9 plus 1. 4 times 9 is 36 plus 1, which gives us 37. So this guy here has a length of 37, and this guy here also has a length of 37. So the question's asking you to find the perimeter, so we're going to add all of these up. Our perimeter is equal to 19 plus 37 plus 37 plus 12 plus 12 plus 19. Or in other words, we can just say 19 plus 37 plus 12 times 2. And that is equal to 136. You're also going to get problems tonight that look something like this. Okay, if it looks tangent, it is tangent. And it's going to tell you something like this guy here has a length of 2, and this guy here has a length of 6. You have a right angle over here on the outside. It's a right triangle, sorry guys. Okay, so if that guy there is 2, we know this guy right here also has to be 2, which means this guy here has to have a length of 4, because the 2 plus 4 have to give you 6, which means over here has to also be 4. There's some other information they're going to give you on your homework, but I just wanted to bring that to your attention. They're going to give you something right here. You're just going to have to translate it over here because it's the exact same length going from the center out, has a length of 2, and then you subtract for the entire length to figure out what this guy is right here. All right, guys, so if you have any questions, go ahead and text me or email me, and I'll respond to you as soon as I can. Otherwise, your homework is up for you on GoFormative. Thanks.